Okay, so welcome back. This is part two in our series, our YouTube playlist, where we are going to design and build what you see here, this box. And this is what's called a remote data acquisition and control device. And what that means is you can take this device and locate it hundreds of feet away from your computer, your Wi-Fi router, and have it access data, measure data, and or you can have it control objects and have it communicate over Wi-Fi with your computer. And you can see we've got this nice Wi-Fi antenna on it that gives it a 300, 400, 500 foot range where you can control objects and do data acquisition. And what we're doing in this particular project, as an example, we are using this device. We're locating it maybe 50 feet away from our computer, and we're using it to measure the real-time frequency of the wall outlet voltage provided by the power company. You can see we've got two wires coming in here. One of those is the wall outlet voltage coming into this device, and it's taking that voltage, calculating the frequency, and every half second sending the resulting measurement over Wi-Fi to our computer. And then we're taking that data, and as you can see here on the upper right, we've got a window in an application we're developing that is charting in real time that resulting frequency. And you can see we've got 60 hertz here. It's going up and down around 60 hertz in real time, and we're showing the last 30 minutes of measured frequency. And down here we've got another window that's giving us, in bright yellow here, we've got the real-time update of the every half second frequency and some other data here. And we are also, in order to verify our data, making sure that it's correct, we are comparing it with this website, which is the University of Tennessee. It is a worldwide frequency monitoring website where they have monitoring devices all around the world, and they're showing in real time, based on these colors, what the relative frequency is of the power system. I encourage you to look at part one in this series. We talked about all of this in detail and what this is and why this frequency is so fascinating. What we're going to do in this video is going to take the next step, and we are going to open up this box and look inside and see what are all the components and figure out how we can build that, what it's going to take to build the hardware. And then in future videos, we're going to look at the software, which is the really important part of all this, because without the software, this hardware would just sit there and look stupid. But we're also going to look at how we can develop the software to talk to this device over Wi-Fi using TCP and all the other protocols. And ultimately, we're going to get this working over Wi-Fi. So let's take a look at the general design of this box, and then we'll go to the bench and open up the box and see what hardware we have. So at the core of this device is this Arduino Uno with built-in Wi-Fi. Now, I've done videos previously going into detail about this. I encourage you to take a look. But basically, we've only got a few inputs and outputs. On the top here, we've got power in into this barrel jack. It can accept 7 to 12 volts DC, or it can be powered by this USB. And also you can communicate with it by this USB. You can also can communicate with it over Wi-Fi. But we basically are going to have two inputs, one for power and one for USB. And then, as we said before, here on the bottom right, we have got wall outlet voltage converted to a square wave, and it's coming into the digital pin on this Arduino. And we are using that square wave to calculate the frequency inside the Arduino. And once it's done calculating the frequency every half second, it's going to send out over Wi-Fi a string that contains the latest measurement, in this case 60.04, going to send it over Wi-Fi and go to your computer. Here is a little bit more detail on the general design of what's inside that box. Again, we've got 120 volts AC, 60 hertz here in the US coming into the box, and we've got a fuse and a transformer that takes 120 volts to 12 volts. And previously we talked about this little circuit here that is going to take our 12 volt AC RMS sine wave and convert it to what you see here, which is a square wave. And we can feed that square wave into the digital pin on the Arduino, and then the Arduino can use some event data to set an internal timer and figure out what the frequency is. And also it's going to give 5-volt DC output that's going to power this little circuit. And we'll talk about that. We also have down here on the bottom a wall adapter, 120 volts to 9-volt DC, that we're going to use to go into that barrel jack, into this barrel jack here, to power the device. Again, we could also use like a USB battery to connect to this micro USB that you see here. And we can also connect a USB to the computer to communicate and to program it. And then ultimately the output is going to be this antenna sending Wi-Fi, this string, every half seconds over Wi-Fi. So it's a very simple circuit, and we're going to take a look at the different components and how to bring them together, what components we need, how much they cost, and so on. So here's some of the parts that I'm using. You can modify this however you want, but this is just the basic components. I talked previously about the inexpensive Arduino with built-in Wi-Fi. And when I bought it, it was only like $5. You can look around. There's different versions, different prices, as with anything in the real world. But something like $5 for this Arduino over here. DC wall adapter, which you see here, which is 120 volts to 9-volt DC. You can get different variations. I paid about $10. You're also going to need a transformer, 120 volt AC to 12 volt AC. I paid about $17 for it. And then this project box, I paid about $18 for it. You can get different versions. This is a nice one. It's metal. You can get cheaper ones, plastic, whatever. Antenna, I paid about $8 for 2 antennas. And then there's going to be, we said we need a fuse for the transformer, so it's going to be another $8. And then some other components, barrel jack for the DC input, power cord, strain relief. And then also we're going to talk about a board that we're going to build for this that has this opto-isolator circuit on it. And we're going to build our own board, and we're going to go to Osh Park or other electronic circuit board manufacturers. And for only like $10, you can have all the components and you can have them build the board, and you can outfit the board and mount it. So we're going to talk about that. But altogether, this is going to be maybe $80. You can probably do a lot better than that if you get different components, but I paid about $80. So those are the basic components we're going to need. Now, we have already covered in our videos, there's a lot to this. There's a lot of hardware, there's a lot of software, and we've already covered areas in previous videos, like we went into depth on this inexpensive Arduino with Wi-Fi. Also, we did a video on Wi-Fi antennas, how they work, what they are, and the zero crossing opto-isolator circuit. We talked about that. And we also did a bunch of videos related to this on software. What is TCP/IP communication over Wi-Fi? That's how we're going to talk over Wi-Fi with our computer. We talked about client-server configuration, which is very important. And we also talked about automatically disconnecting and reconnecting of this device. If it loses signal or whatever, you want to make sure that it will gracefully disconnect and reconnect without crashing everything. We talked about Arduino timers and events, which are needed to take that square wave and calculate frequency. We talked about data acquisition and filtering, so we can filter the data coming in, get rid of some of the noise. We talked about data parsing, error checking, and verification. We're going to need, when we get the data, make sure it's good, it's not junk. Low pass data filtering is one of the tools we use to filter the data. And then we talked about C#. This application we showed is in C#. We did charting, that scrolling chart, 30-minute chart, Windows forums, and having multiple forums. So there's a lot to this. A lot of it is software. Again, hardware does nothing. They just sits there and look stupid. You have to write software. I know people don't like software. They just like to play with hardware and flashing lights. But in the real world, you need to know software if you're going to know how to make hardware do things. Otherwise, it's just going to sit there. So if you haven't done software before, I encourage you to look at my 3-part series on writing your first software application. Very, very easy. Using C#, you just drag and drop some components. We also talked about electric power system frequency, which is what we're monitoring with this box, and how fascinating that is. And it's kind of a heartbeat of the power system that's feeding your state, your country, whatever. So I encourage you to take a look at all these videos and learn something about what we're doing here. So now let's go to the bench and take this apart and see how we implemented basically this design and these components in this box. Okay, so here's our box, and let's first take a look at the rear. And what I've got is I've got the antenna right here, and we've got two inputs. This one on the left is the barrel jack that is going into the Arduino Uno, and this is where we get the 9 volts coming in to power it. And here is directly from the wall outlet going through a strain relief, and this is going to go into the transformer that's going to give us our 12 volts. And then we've got the fuse here. I've got a 1/2 amp fuse on the primary of the transformer, and that's about it. Now you can add to this if you want to have a terminal here for input and output. We're just having this one input, which is the 120 volts AC coming from the wall outlet, so we can measure frequency. But you can put a strip here with connecting to the digital or analog inputs and outputs of the Arduino. And on the front, we've got a connector here that I've added in case we want to power the Arduino from a USB battery, and I've done videos before on USB batteries. And or if I want to communicate and program the device, I can just plug in here and that will power the device and that will allow us to program it. So let's take a look inside and see what we got. So here is the inside of our device. You can see got the main transformer. I've got the Arduino Uno. I've got the USB coming in that's connecting to the USB here. And on the front panel here, I've got stuck to the front panel with some double-sided tape the opto isolator that takes the transformer output, converts it to a square wave. So let's take a look at that circuit. Here is the circuit, and this is something that I spent just a few dollars to have fabricated this board and the components, and it was only like $5 or $10 at Osh Park, and we probably in the future will show you how to design these circuit boards, and very inexpensive to get these boards made. And this is basically stuck on this panel. So if you're interested in any of the specifics on these devices, I've done a video on this, and I've done a video on multiple videos on this Arduino Uno with Wi-Fi. So again, these devices are readily available at Amazon. Here's the project box, $18. They've got a whole bunch of different sizes. The transformer is a 110 volt to 12 volts, 10 VA, and the DC power supply, power adapter, you can get those anywhere. Very common. And all the other components you can look up on Amazon pretty easy. And as far as that opto isolator board, again, I did a video previously on it. You're just taking your 120 volts in. This is a LT Spice simulation, by the way. I've done videos on this. And 120 to 12 volt transformer. We've got a low pass filter with an R and a C, and then a diode, another resistor, and a PC817C opto coupler. And basically we're getting the 5 volts from the Arduino and just feeding the output of that opto coupler a square wave going into the D2 and ground on the Arduino. Very, very simple, straightforward. Again, I've got videos on all of this stuff. So that's about it for this one. I think in the next video we're going to look into more of the design requirements for this and see how we can put it together. So if you like any of these videos, I encourage you to hit the like button, subscribe, hit the bell notifications, but most of all, please let others know that we're here so we get some views. Really appreciate it. Otherwise, take care. Have a really good day. Thanks.